With the release of Golden Gate, we now have Box Joint Basic as a free extension included. We're going to walk through the process of creating a box. In this case, it's going to be a 9 by 3 high by 12 long box with a little 1/4 inch panel in the bottom. And we're going to assume you've prepared your stock material and then show you the entire process of creating the box joints with Origin with the new extension. Depending on the configuration of the box, the size of the slots, the size of the cutter you have installed, you're going to want to deviate and always do a test cut first in the stock material. So take an off cut, perform the test, and then confirm that the joints mesh nicely. But we'll take you through an example of a way to create this with Origin. One quick note before we kick off, there's a PDF version of this document. So if you're more interested in learning by flicking through a hard printed manual, take a look at that. It's got lots of diagrams and all of the settings are clearly called out. Follow along with the video to see how we're configuring things and approaching this. So we'll start off here with our panels, and we're going to just lay them out and make sure that our grain and everything is as we would like. So you're going to want to pay attention to the finished side. You want that on the outside, depending on how you want it. Match the finished edge if you want it on the inside or the outside, depending how your box is set up. And then also you're going to want to make sure your jointed reference edge is facing the same way. Pay attention to how the grain flows around the outside. If that's a critical element of your design, go ahead and do that. So this is going to be a 9-inch box by a 12-inch box by 3 inches. Measured this. Our stock is already tuned up nicely, so it's pretty much bang on. So once they're actually cut, they're going to overlap because the pins and the cavities are going to interlock. The next step here is to mark up these elements. So I'm going to want to be able to make sure I'm always in this format, always with my reference jointed edge, indexing against that jointed edge. I've just put a little triangle here, and I've called these sides the B sides. So you can see here we put a little triangle and just write B in that. And then these sides, the A sides, so that's my front and back. So now from any position we can guarantee we can get our panels back into that same orientation. Like it's clear which side's up, which side's down, and what is in and out. So we'll put these to the side and then we'll quickly start fixturing up this panel. So first things first, we'll start with our A sides. You're going to want to develop a routine here where everything's done consistently, and we're going to index against that reference edge. So that edge aligns with our pins here. So we won't worry too much about the height just yet. We'll just loosely clamp this on. If anything, we want it to be vertically a little proud because we're going to push it down in the next step. So the big thing here is to keep these pins indexed firmly against that. That's the most critical alignment. So it's got to be dead vertical, flush with the top, and flush with those pins. So then we can tension these up. It is important to put a reasonable amount of pressure on it, and then just double check to make sure it hasn't been pulled away from those reference pins. In this state, you can be confident you're going to get a good outcome. Now, the depth we set is exactly the depth we're going to cut, and there's no drift left and right because we're perfectly aligned with those pins. So once we're satisfied with how we have our A panel fixtured up there, we will go ahead and perform a scan. With the box joint basic, we won't need to return to this. So we scan once, and that will be the only scan we need to do to create as many boxes using the same dimension. If we had a bunch of this stock and made 50 boxes, we could just scan once and then just continually place in a new panel and cut either the A or the B sides. We've scanned in. So I'm going to quickly show you how box joint presents itself. So first up, if we kick off box joint without a grid, it's going to help us. So it's under Design, Create, Box Joint. And if we don't have a grid in place, it's going to remind us, hey, you need a grid. We can ignore that and try and place it by eye. That's kind of a waste of time. You're not going to get an accurate alignment. But if you just want to mess with that shape somewhere else, feel free to do that. Usually you're going to want to say Create Grid. Now it's moved us into the grid mode. We do have a 1/4 inch cutter in here, so we're going to create a new grid. We don't need to worry about the actual grid increment. We're going to be placing our shape at 0, 0. We'll create a grid with just the stock 1/2 inch. I'm going to lower this down, probe against the right hand side. So this is going to define my x-axis. So this is just determining where our stock is so we can accurately place on it. So just touch it, come around the corner, same again, y-axis. So now I've defined the X and the Y axis, and I got this grid. So now we can go back to box joint, Box Joint Basic. It's starting us off. We're going to create the A panel. That'll be the front face of our box, and you'll see how that gets chucked up here. So we've got it chucked up in this orientation, and Box Joint Basic is going to create this toolpath, and it's going to help us place that at 0, 0, which will enable us to cut out these slots between the pins. So our job, start with A, fixture it like this, and then now we're going to create this path. So we don't need to do any crazy math to determine the exact dimensions of each pin and the glue gap and all that sort of stuff. Box Joint Basic is going to help us with that. So we'll start with the cutter. Now, these illustrations will tell us what's going on. We're just going to want to make sure that our cutter can fit through those slots between our pins. If we go to create a 1/8 inch slot and we have a 1/4 inch cutter installed, it's not going to enable us to do it. So this just helps us prevent that happening. So we'll leave that at 1/4. Then we'll define thickness. So that's the side wall of our box, the actual thickness of the panel. So the diagram helps us there. So that'll be 0.5, it's already correct. And then we jump to width. So that'll be the height of the box if it's lying as it ordinarily would. So that's the width of our stock there. And that will be 3 inches. And then total pins. You'll notice here we actually count all the pins. So the pins on the A panel and the B panel, as they intersect, we count each one. So this is just pointing out the difference in how pins will look or are configured if you do an even or an odd layout. So if you do an even count of pins, you end up with the outside pin being on either panel. So each panel will have 1 pin on the outside. And then if you do an odd number of pins, you'll see here that the A panel will have the 2 outside pins and the B panel will be encapsulated by that A panel pin. So we're going to kick off with 5 pins, and the next subtlety here is glue gap. So when you bring your 2 panels together, you want to make sure there's enough gap that you can actually get them together easily, but you want a little more than that. So you want very light friction, but enough to just hold it in place. So that enables the glue to form a good bond between the 2 panels. So you're going to want to test this on some example wood that you're going to cut, and with the cutter you're going to use for the cut. Get that tuned up first by cutting an A and a B and test fitting them together. A good starting point is the default here, 0.005 inches. So that gets you a pretty firm friction fit in softer material. So if you go to harder material, you're going to want to make that glue gap larger, so like hickory, things like that. And if you go for bass or crazy soft material, you might want to make that a smaller glue gap, just to keep the friction consistent across those. And then double check it when you change cutters, because the advertised dimension and the actual dimension can differ. Test first and then produce as many boxes as you like. So with that all done, we're in a good place to start cutting. All these settings are appropriate. We can actually pinch to zoom here, and I'll align this to 0, 0. You'll see here our toolpath and our cut area is matching our stock appropriately. One other thing worth noting, in this state we can change all these parameters. Once we place the shape, we'll be able to flip between A and B, but we will not be able to change the remainder of the parameters. So that means our B side is always going to fit together with our A side. We don't end up with discrepancies there. We'll start with our A side and place this joint at 0, 0. Now you'll see here the A's highlighted. So these are the pins that will remain. And what we're actually cutting is this white area here. So that's where the toolpath is going to prop up when we go to cut mode. So you'll see here in cut mode, we're going to remove all this material between these A pins. Now that enables us to cut any dimension pins, providing they're bigger than the cutter we have installed. So you don't have to do any weird designing your shape to be a multiplier of the cutter diameter you have. There's a lot of flexibility here to do whatever you want. Now, we have a 1/4 inch cutter here. We're going to cut quite deep. This is ash. We'll show 2 approaches to cutting, a conservative approach and an aggressive approach. If you're familiar with cutting with Origin and are getting great outcomes cutting end grain, during your test cut, try out the aggressive approach and see if it works for you. It's obviously taking on more risk, but if your cutter's sharp, you're familiar with operating Origin, and your material is soft enough, that's a good way of speeding up efficiency. If, on the other hand, this is your first time creating a box joint with Origin, stick with the conservative approach. So if your cutter gets a bit dull, you're not familiar with Origin, or your material's quite hard, that's the preferred approach. Before doing any cutting, just quickly confirm with an air cut, with the cutter set to the right diameter, that you're not going to collide with anything you want to protect. If you're not using a vertical workstation, there's a chance that you have precious things near your stock, and you'll just want to double check that you're not going to cut into those with your toolpath. First up, we're going to approach this as the conservative approach. So we'll do 2 passes to get us down to our full depth. So a 1/4 inch deep and then a 1/2 inch deep. That means our cutter remains relatively unloaded compared to doing a full depth cut. We're going to do a 0.05 5-inch offset, but it also clears out that piece in the center there. So we're going to plunge off the edge of the stock. So we're not plunging into material, we're plunging in the air, and then we'll gradually ease into the material. There will be a change in forces you experience as it starts engaging with material. So just keep your fingers on the vertical workstation to keep Origin tracking true to that line. So just move in nice and slowly and you'll get a good outcome. Next up, we'll change to a 1/2 inch deep. This is the full depth of our slot between our pins. You'll notice it matches the thickness, the side wall of our panels, because it has to accommodate the panel in there. We're now at 1/2 inch. We'll do another roughing pass, 0.055 inch offset again. Notice we don't need to return along the back edge there. That's just there to close the shape. We're only cutting the area that penetrates the stock. That'll speed things up if you don't come along the back again. Now we're going to remove the offset, put it to 0, and remain at 0.5 inches deep. So this is now our finishing pass. It's a little bit more loaded than most finishing passes, but that was because we were clearing out that center material initially. The best way to ensure you get perfect outcomes is to use a nice sharp cutter, so don't try to stretch a dull cutter too far cutting box joints. Looks good. So we'll pop this out, flip it over. Notice I'm keeping this edge, the reference edge of this panel, oriented the same way. So it's a flip this way. We don't want to start referencing the opposite edge, so if there's any inaccuracies in our stock or any variation, we don't want that to be a misaligned panel. So long as we flip it this way, we get good outcomes. Once again, the most critical thing is to keep this up against this edge consistently, and good clamping pressure. So double check your indexing pins to make sure you haven't drifted off them. If you do, you run into problems quickly. So the opposite end of the A side, now the steps to return to that original state and do an offset. So this is just a roughing pass again. Erase your cut history, then we repeat the same operation. So now we're going to take a look at the more aggressive approach. Also, if you've got wider slots, you may want to look at this option. We're going to use a pocketing operation to clear out the center. So that enables you to do much wider pins and slots. We're also going to cut at full depth and then do a finishing pass that's more modest, a 0.01 inch finishing pass. These are 2 different techniques. We're just getting them in front of you. You can experiment with them with your stock. Having racked up the first side A panel, we're going to start and cut 1/2 inch deep and set that here. We're going to do it in one pass. So we're going to do a roughing pass. We're going to add a little bit of material that will then remove with a follow-up pass. For each end of our panel, so for each operation, we're going to do 3 passes for this particular one to remove all the material. So it'll be a roughing pass at full depth, followed by a finishing pass at full depth. Then we'll convert to a pocket and clear out that center area. That's all that's required to remove all the material for this edge of our A panel. Now, the other thing to note, great place to start is the bottom left corner off in air. So we want to be off the edge of the panel, and we'll gradually ease into it as we go here. So for that first one, it's just a smooth cut there, and we don't need to return along the bottom there. That's just for a closed shape. We don't need to cut all of that. You can see the area where the stock is, that's all we're clearing out. Then we convert to a finishing pass, same again, but in this case, this is the most critical cut. We want to just move slowly and smoothly to get a good outcome. The remaining operation is to convert your path to a pocket and just remove these central areas. So we'll do that now. Looks good. So we'll pop this out, flip it over, double check your indexing pins to make sure you haven't drifted off them. If you do, you run into problems quickly. So the opposite end of the A side, now the steps to return to that original state, erase your cut history, convert back to an inside cut, and do an offset. So this is just a roughing pass again. Then we repeat the same operation. Next step, we remove the offset. So now we're doing the finishing pass. This is the most critical pass to make sure you get a good clean outcome. Move smoothly, especially vertically. So you don't want to drift sideways too erratically. You notice we overshoot a reasonable amount to try and protect you from inadvertently cutting into those pins. With that complete, we then go to make our toolpath a pocket and clear out these center areas. Having completed both of our A panels, both ends of each, with an A profile cut, we will then move on to the B panels. So just fixturing up our B panels and cutting each end. So same process applies. The little mark, reference edge, gets aligned with the index pins. We fixture that up and then make sure the top is level and cut this panel. You'll see here in design mode, we hit swap. So this keeps all the parameters the same and just swaps to the mating B profile cut. So then we can go to the cut menu. So we just make sure we start on the bottom left of the material and we're going to do a roughing pass initially. Same parameters as we did for everything else. So 1/2 inch deep, 0.01 inches offset, that's our roughing offset. And then we start cutting our first B panel. Just gradually push in there, make sure we're running our spindle fast enough to remove material. And cut that out. The second pass is the finishing pass, so same as we were doing on the A panels. And you'll see this has got 3 slots we have to take care of. Same routine, convert it to a pocket. You want to maintain consistent downward pressure with these handles so that you get a consistently flat surface on the back edge of these cuts. And that's it for the first B. We then take that out, flip it. Same approach to flipping. Keep it oriented the same way. Keep that edge against your index pins. We'll do this 3 more times, so one to the opposite end of this, and then the other B panel, and we'll be able to fit these together. You'll see here we have a box that fits together with all the appropriate friction and nice clean joints there. So that's now a 9x12x3 box. Now that we've cut our box joints, we're going to move on to the dado. Now the interesting thing here is, the reason we're not doing this on a table saw is we need little blind dados along our A panels. So we're going to hide them inside of our pins so they will not protrude out the side of the box. If you ran that through a table saw, you would get those popping out the ends and it would be an ugly thing you would have to patch later. We're just going to use the pen tool to quickly create a dado into our A panel. First, we're going to set up our panel for installing our little dados. So our tape field needs to be at the same height as our side panel here. So this is 1/2 inch thick. We're going to use 1/2 inch ply with tape. It needs a clean, straight reference edge along the front of it. That's all that really matters in that. And then we will get a little square that will double-sided tape down against it, just as a reference point so that we can put both A panels in without having to rescan and re-grid up to identify where our stock is. It can continue to be placed at the same location and we can repeat the same cut. Double-sided tape on the back of these panels, configured like this with the little indexing element at clear 90 degrees to the left of where we're going to put our panel. We now need to take origin and grid, and we're going to be identifying this corner here. We're using the inverted engraving cutter, so we're going to set the diameter of our cutter to 1/4 inch, and then we're also going to set the grid increment to 1/4 inch. This means that when we probe here, here, and here, we will get a grid that's just 1/4 inch in from that edge. It always assumes it's probing on the right, but because we're using a 1/4 inch cutter and our increment is 1/4 inch, we effectively get this edge. So we need to identify the top of the A panel and the inside. So we need to know where the inside is. That's where we're going to be cutting. So we want to tape the opposite side, double-sided tape, and then push that hard into the corner. Now all three of those panels held in place by double-sided tape and won't move during cutting. So now that we have our tape field and our reference index panel set up, all at the same height, 1/2 inch high, now we're going to use the pen tool. In the create menu, you'll see pen there, and we need to go and find this corner. So you'll notice the far left corner is actually 0 in Y and -0.25 in X. So we're going to want to place our first point here at -0.25 in Y and then at 0 in X. So we can just check physically where the cutter is here, just to double check we're going in the right place. So we'll go from -0.25 in Y and 0 in X, then we go 8.5 in X and -0.25 in Y. And we add another point there. Just double check, make sure your line is perpendicular. It'll be apparent if you've gone at an odd angle. So that line's now available for cutting. So just to double check with an air cut, we can plunge down at the far right end of our toolpath. And looking at this, we can see clearly the edge of that cutter is about 1/8 inch in from the edge and from the base. So that makes sense if we're running along the center and we're 1/4 inch from the edge. Okay, looks good. So now that we're going to cut this, because we've chucked up a new cutter, just make sure you do a Z-touch, and then we'll do the first pass 1/8 inch deep, and just perform the cut operation exactly the same as we did for the air cut. Start on the right and work all the way across. With this one, you want to be very smooth and linear with your motion. You don't want any variation being apparent in this cut, because you'll see it from the top looking into your box if you introduce any waviness. That's why we're doing it in 2 passes. This one's kind of a critical one to get right. Follow that with a 0.3 inch depth. Technically 0.25 would have a hard fit. There'd be no breathing room, no tolerance to accommodate any variation in either our box or our base panel. So we're going to do it just slightly larger on all sides. So we're going to cut to 0.3 inches deep instead of 0.25, just to give it a bit of room to move there. Should things expand, contract, whatever. 0.3, same cut. Be sure to vacuum out any chips or anything if they're left in the cuts along the way. Just lift up this edge, make sure you don't mash a screwdriver in this. If you can just get in there with something nice and flat like this little pry bar, you can pop these off very cleanly without damaging the fibers in the corner of your pins. Now you can take our other A panel and just identify the top and the outside face, double-sided tape that, the same as we did the previous one. And now blow out the dust in the corners of our little fixture and then press that in so we have the inside of the panel facing up. Now that we've tested this with the previous one, we can just return to the 1/8 inch cut and follow up with a 0.3 inch cut. So exactly the same process. For the B element, we'll do the exact same process. Tape the outside, make note of the top, and put the bottom against your panel. The difference with this one is we're going to cut the whole way through the material. So the dado runs and it's not blind, it continues out the ends here. We'll bring the tool down in design mode. We're going to delete the old one with the little trash bin. And then grab the pen tool, and we're going to start at -0.25 in Y. X will be 11.5, and then we're moving all the way down to X will be 0, Y will be -0.25, and click twice there. So make sure it runs orthogonal, parallel to your panel. So at this point, we can now cut that dado along the bottom. We'll do the same process, 1/8 inch pass, and then a 0.3 inch pass. So we'll repeat this for both the B panels and we'll be ready to assemble our box. So now all of our components are good to go. We can just press fit this box together by hand. If the accuracy of our cuts and the test cutting process was carried through, you'll get a box that fits together perfectly, press fit just by hand. You won't have to hammer or clamp or do anything too excessive. So that should be a beautiful finished box.